Principle of step up operation. So here we are studying step up DC to DC converter. Here source voltage is shown here. So this is an inductor, this is a switch, this is a diode, this is a load. Sometimes we are connecting a capacitor parallel to load. Okay, right now we no need to worry about this capacitor, just concentrate on source voltage, load, inductance, no, not it is an inductor, L, switch, diode and load. Okay, so this works in two modes. Mode 1 is when we close the switch, and mode 2 is when we open the switch. First of all, we close the switch. When you close the switch, what happens here is the current is flowing in this way, because the source voltage is there, your inductor is there. Okay, so switch is closed, so the current is flowing in this direction. That's the reason I've shown here the current is flowing in this direction. So this diode is not in on state, so there is no connection between load and source side. The load is load side, the capacitor and the load, this is parallel to each other, and this part is completely detached from the source end. The current from this source is flowing through inductor, or else I can say that energy which is available in the source side is given to an inductor, the current is flowing in this path. Okay, so EMF is induced in an inductor, is the EMF which is induced in an inductor is in such a way that it is opposing the current flow. So okay, so actually the sign of the EMF is positive this side and negative this side when we are closing the switch like this, or else in the mode 1, because this induced EMF should oppose this current. Okay, so the current rises during this interval. The I1 of t changes from one's current rises like this. This is a steady state current. So current rises in this way from I1 to I2. During this interval current is increasing from I1 to I2. Means if you consider that its initial value is I1, inductor current, it is changing to I2. Okay, so when the current, the mode 1 begins like this, current is flowing in this way, current is changing like from here to here. This is in T1, means from 0 to KT. So we'll use KVL for this. So Vs minus L di1 by dt is equal to 0, correct? Vs and inductor voltage, only both two things are there here. So that's the reason Vs minus Vl is 0, Vs minus L di1 of dt is equal to 0. We are calling this current as I1. So Vs, so L di1 by dt, is Vs by L. So if you call change in current is nothing but I2 minus I1. I will call that as delta I is Vs minus Vs, then this delta I, this is di1, Vs by L as usual. Dt is timings from here to here, change in time is kt minus 0, that's the reason kt. So delta I here I called as I2 minus I1. I2 minus I1 I will call as delta I. I2 minus I1 we got an equation like Vs by L into Kt. You call this equation as 2. Okay, so you just think what happens when I open this switch. We open this switch. This is mode 2 operation. When you open this switch, so assume that in the previous mode, in a mode 1, current is flowing in this way. Here there is a switch. When you open this, what happens means the EMF which is induced in an inductor, the sign of the EMF, induced EMF sign will change. Means if earlier this side was positive and this side was negative, means now this side becomes negative and this side becomes positive. Okay, the sign reversal of an induced EMF take places when you open this switch. So when you open this switch, here there is a switches, correct? When you open this switch, means in the main diagram, when you open this switch, current starts, see this voltage and this induced EMF. As I told, in the mode 1 this side plus and this side minus, in mode 2 this side minus and this side plus. So induced EMF is adding with this voltage. So these two voltages will transfer energy from this source side to load side. So this diode is forward biased. Okay, this energy added with this energy, and finally sum is transferred to this load. Okay, so I can say that. So equivalent diagram Vs L di by dt, and anyhow this switch is open, so no current, and the diode is forward biased. As we have shown here, this diode, this diagram, this diode is forward biased. So load and capacitor, you no need to worry about this capacitor, it is connected parallel. Okay, so if you write an equivalent circuit for this, source voltage is there, inductor is there, load is there. Okay, you apply KVL for this. So if you apply, so as I shown here, now I am this voltage and this voltage, totally it is this will transfer energy from this source to load. So power is delivered to load. So during that time current will fall from I2 to I1. Now load comes into picture. In the previous there was no load, this energy was transferred to inductor, so current rised in this way. Now the energy is transferred from source to load. So this voltage along with the EMF induced across an inductor, both are added up and is given to load. Can you wait for 5 minutes? Given to load. So given to load. So next, that's the reasons current is changing from I2 to I1. This happens in between Kt to T, and this happens in between Kt to T. This is mode 2 duration. In mode 2 duration, so energy is transferred from source and energies means source and energies, this voltage along with the inductor voltage, both are added together and is given to load. Okay, so if you apply KVL for this mode 2, so Vs minus VL means this inductor voltage minus V0, this is minus V0 is equal to 0. So we are always leaving end is minus, that's the reason I have taken minus. Here leaving end is plus, that's the reason Vs. So source voltage is constant Vs, VL is L d I2 by dt, di2, this is an I2, di2 by dt, V0 is what? L. What is di2? di2 is nothing but I1 minus I2, I1 minus I2, I1 minus I2. So I1 minus I2 is nothing but minus of I2 minus I1. What is I2 minus I1 is delta I. That's the reason I1 minus I2 I can call as minus of delta I, Now, there is no minus here. This is I1 minus I2, delta I minus V0. if you rearrange this, so what is dt here? Dt here is time duration between this t and kt. That's the reason it is dt is nothing but t minus kt. If you keep outside t 1 minus k. Okay. So vs, so this has becomes plus l di 1 minus kt is v naught. So vs, so you just what is delta I? Delta I we have already derived in the previous equation. Delta I is nothing but Vs by L into Kt. If you substitute this equation here, Vs by L into Kt, so L 1 minus Kt, delta I is Vs by L into Kt. So L cancelled each other. So Tt cancelled each other. So anyhow I have written like 1 plus kt by 1 minus kt, t minus kt, kt 1 minus kt. Anyhow you can simplify it. Vs into t 1 minus kt, tt cancelled each other, v naught is equal to 1 minus k. So if you simplify, v naught becomes Vs by 1 minus k. You can see here, if the k is 0.5, 1 minus 0.5 is 0.5. So Vs by 0.5 means v naught is equal to 2 into Vs. If k is 0.5, output voltage is 2 into Vs. We can boost. If you increase k, if k is 0.25, 1 minus 0.25 is 1 minus 0.7. If your k is 0.999, what happens? 1 minus 0.00001 is how much? So if k is 1, v naught is Vs by infinity. There is no meaning. It's not correct because we are not keeping k is equal to 1. So I can show you, if you increase k like this, the v naught by Vs will increase, means gain, means step up operation. V naught by Vs, so v naught is 7 times of Vs here. So if k is 0.2 like this, if k is 0.4 like this, 0.6, so if you increase k, v naught will increase. That is a meaning. So we can step up to any, but if you take very high values, the v naught theoretically will goes to very high values, but it is there is a limit, because practically everything is not possible. Okay, next, if a large capacitor is connected across a load, the output voltage is continuous and V naught becomes average value VA, because practically we are connecting a large capacitor across a load, so that output voltage is continuous. The output across a load can be stepped up by varying the duty cycle K, and the minimum output voltage Vs is when K is equal to 0. Okay. However, the converter cannot be switched on continuously such that K is equal to 1. So K is equal to 1 is not practical. So simple here. What happens when you close a switch? The EMF is energy which is there in Vs is given to Vs inductor. So EMF is induced. The sign of the actual sign of the EMF is plus and minus this side. So later when you open this, the sign reversal of EMF take places. So this side becomes minus, this side becomes plus. So minus plus. So this voltage is added with this EMF, and all together is transferred to load. So load voltage is anyhow more than this. Okay? So by doing this again and again, we can, on an average, we can step up the voltage. Thank you.